Hey everybody, it is me, Steve. It is January 5th, 2018. Time is 1833, and this is going to be part 2 of our planned observation of the lunar transit of the ISS on January 27, 2018. But before we can actually go do this, we need to see if the equipment we're going to have will be able to photograph or record the actual transit. Now, thanks to Wolfie 6020, I have found the method. He did the same thing of calculating and building a 2-scale model of what the ISS is going to look like at 100 meters distance. So you go to the angular size calculator, which is here online for free. And first what we do is we need to we need to build our model. So we know that the ISS is going to be about 853.1 kilometers from us, and the ISS size at its widest point is about 109 meters, or 0.109 kilometers. All right, so we plug that into the calculator, and we get 0.0732 and some change degrees. All right, so what does that mean? Well, we need to translate these degrees into meters. All right. So then we take our 0.00732 and some change, and we plug the distance we want at kilometers, or at meters, my bad, which is 100, and we get 0.012777, which is 1.2777 centimeters. All right. Now, here being in the U.S. and all my measuring implements are imperial, I need to translate everything to inches, and I'm going to show you a video of the actual of my drawing that we're going to use when we actually go out and test this. So 1.277 centimeters is roughly half an inch in diameter. All right, and 100 meters is roughly 328.084 meters, or 328.1 feet, roughly 328.1 feet. So, what are we going to do? Sorry, I gotta close and open up some windows because this thing doesn't do things in order. All right, so I've found a place we can do this to set up our experiment to see if we can actually pick this stuff up. And this is just a parking lot, and the yellow line here, as you can see, this is from Google Earth. The length of this parking lot along that yellow line is really close to 328.1 feet. So we're going to use this. All right. So we're going to use this parking lot. Now we need to be able to see a 0.503 inch object at a distance of 328.1 feet. Okay, so that's that. And our line, I bolded it for you. And our heading is going to be 18.98 degrees, which is roughly north 19 east or south 19 west, because I will be making sure this thing is lined up with a Brunton compass, and the Brunton compass I have is quadrant. The beauty of it is if you need something 180 degrees from a measurement, the number doesn't change, just the heading does. So that's the beauty of doing that. So this is what we need to do, and this is where the experiment is going to take place. Probably going to do it on Sunday. It's bitterly cold right now and has been for well over a week, but Sunday it's supposed to be in mid-30s. That'd be Fahrenheit. So I'm going to show you now the video of my 2-scale ISS drawing, and hopefully on Sunday this will work out.
Okay, here is the diagram I have created on cardstock that we are going to use to test and see if Sarah's camera can even pick up the ISS. According to my calculations and stuff that I showed, we should be able, the ISS would be equivalent to something half an inch in diameter at 328 feet. All right, so this is my American geologic protractor, which of course is in inches. That's why you see me translate everything into inches and feet. So the 328 feet, by the way, would be equivalent to 100 meters. But just to show you that this is the actual size I say, there's tenths inch scale. As you can see, my sloppy marker drawing, it's pretty close to half an inch. I used other bar scales here for comparison. We have, because if we can't pick the ISS up, I'm hoping we can at least pick up one of these other drawings. There's a 1-inch bar. There's a 3-inch bar. And this is a 6-inch bar. So if during our test, if we can't pick up this, hopefully we can at least pick up one of these other ones and see what kind of magnification we would need in the future. But I think we will be able to. I think Sarah's camera is accurate enough or good enough to actually pick up at least we may not see it this kind of resolution, but we should be at least able to see it.